So there are a couple of microorganisms that pose serious risks for consumers, and among them we have Listeria, monocytogenes, E. coli 0157H7, and Salmonella. The two ones that I mentioned first, Listeria and E. coli, they are the most fatal ones, and so whenever there is an outbreak, they tend to take people to hospital, and sometimes if they are immunocompromised, they can actually die. So if you can detect those microorganisms as fast as we can and as in low concentration as we can, and ideally in a processing plant, real time, we can provide a much safer food process material. So especially for fresh produce, where we don't have any killing step that is effective enough nowadays, if we are able to detect the contamination before it actually leaves the plant, we are making sure that we have a safe food supply. So in the case of Listeria, for example, one of the major problems is that it's a microorganism that can grow under refrigeration. And that in itself, just having the fresh produce, for example, is stored in a refrigerator, it allows them to grow to concentrations that are actually infectious to the human being. So that's why we wanted to be able to detect them as fast as we can. Real time, that's what we call. And we are working right now in developing biosensors. So biosensors, the idea of them is to be able to detect bacteria real time. And we use electrochemical approaches to do so. And the one that we are currently developing right now is that we don't need a pre-concentration step for the sample that we are trying to detect possible contamination. We actually use the sample as they are. And what we have come up with is that we have we developed those polymers. They work as like cilia, and they behave like, we are trying to mimic this bob squid, Hawaiian bob squid filtration system. So they work as a capture and release. So as the material passes through those polymers, they will grab the bacteria that we are interested in detecting in a much more efficient way. And as they do that, they change conformation, and we can actually detect using electrochemical approaches. So we are working on developing that, and particularly we are focusing on Listeria because of the risks that an outbreak with Listeria can affect the population.